Hello, everybody, and welcome to lesson 7.4 for Math 9. What we're doing is we're taking shapes and we're moving them around all crazy and such. In the previous lessons, what we did was we took shapes, we made them bigger, we made them smaller, we did all kinds of crazy things. Now, today, what we're going to do is something called translations. Translation. To do a translation just means to move up and down and or left and right. So we're going to take objects and we're just going to move them around. We're going to move them up, down, left, right. We're going to move them all over the place on a Cartesian plane. That means an XY axis. This should be one of hopefully the easier things that we do in this unit. We're going to do these translations, by three different methods. First method is going to be words. That's probably the easiest one. They're going to give you a shape. They're going to tell you to move that thing 3 units left, 5 units up. They're just going to use words to describe the movement. The next way that they're going to do this is by using coordinates. So instead of actually using words, they're just going to use something like this. And that's going to tell you the first thing is telling you left, right. So -3 would be 3 left. And then 5 would mean 5 up. Kind of like an XY coordinate, but now it's the whole shape is moving to whatever those coordinates are deeming you to move. That is very rare, and we don't really do much more coordinate movement after this here. The third way, and probably the most important way, is called mapping notation. I'm going to add the word notation in there. It's funny, we don't do mapping notation again until grade 12, but then it becomes very important in grade 12. Mapping notation looks something like this. That would mean take your x values and go 3 left. And that would mean take your y values and add 5, which would mean 5 up. We do see a little bit of that in Math 20, not a lot. We don't really see it in Math 10 at all. And then in Math 30, it comes back all of a sudden. So mapping notation will be kind of important to get you a base for grade 12 math. Okay, let's just jump into it. So we're going to graph the image of the figure using the transformation given. A, we want to take this shape. We want to go 5 units right and 3 units up. The best way to do a translation is to move each point that far. So I'm going to start with point T right here, that corner, that vertice. I'm going to move it 5 to the right. 1, 2, 3, 4, 5. And then I'm going to move it 3 up. 1, 2, 3. That is now there. That is point T prime. I call it prime because it's not point T anymore, right? Because I've moved it. Point T was the original point. And I'm going to do this with every single point. So I'm going to take point G. I'm going to do the same thing. I'm going to move point G 5 to the right. 1, 2, 3, 4, 5. And then 3 up. 1, 2, 3. So point G prime is now there. The beauty of translations, and what we're doing here today, is that the order in which you move them doesn't matter. So I'm always going right and then up. You could technically go up and then right. So I'm going to do that with point B here. I'm going to go up 3, 1, 2, 3, and then to the right 5. 1, 2, 3, 4, 5. So the order doesn't actually matter in which you do them. That gives me point B prime. Beautiful. You have officially translated your corners or your vertices. Now all I need to do is play connect the dots, which is nice and easy. I'm going to try to make this line a little bit thicker, go with purple so it stands out. We just connect the dots. And we have our shape. Oh boy, that's why it was doing such crazy things. I'm not drawing lines, I'm drawing boxes. There we go. Awesome. We just translated that shape 5 to the right and 3 units up. When I'm marking this, what I'm going to mark is the corners. That's what I'm looking for. And then I'm going to look to see if you did straight lines connecting them. So make sure you properly move the corners. Perfect. That's translation using words. If we look to the right, we have over here translations using a coordinate. So they didn't use words this time. They just used a coordinate like this. When they ask you to do a transformation and then only give you a coordinate, the first value is left or right. The second value is up or down. When you're looking at this, positive numbers are right and up. Negative numbers are left and down. So positive numbers are right and up. Negative numbers are left and down. So if I was to look at this question, this coordinate, what it's telling me is to take my shape and go 3 to the right because it's positive. And the second number tells me up or down. This one would be 4 up because it's positive. I'm going to go to my shape and I'm going to do exactly that. I'm going to start with point G over here. Doesn't matter which point you start with. I'm going to go 3 to the right, 1, 2, 3, and then 4 up. 1, 2, 3, 4. So I now have this point right here, G prime. Beautiful. I'm going to keep doing that. So I'm going to take point Y over here. I'm going to go 3 to the right, 1, 2, 3, and then 4 up. 1, 2, 3, 4. And I'm going to call that point Y prime. I can't call it Y because point Y is the original point, right? That's why I put that little apostrophe and I call it prime. M, I'm going to move 3 to the right, 1, 2, 3, and then 4 to up, 1, 2, 3, 4. So I now have point M prime right there. And again, now that I've moved my corners, I can easily connect the dots to create my shape. Like that. There's my triangle. Easy peasy, right? As long as you know what the question is telling you to do, the actual work isn't that hard. So the hard part on this question is remembering what a coordinate is telling you when it comes to transformations. The third way that we do things is this right here in part C. This is called mapping notation. It's kind of like doing a coordinate, except what they're doing is they're saying you take your x values and you move them -4. So for instance, if we looked at point U right here, point U is at -1, sorry, no it's not. Point U is at 0, -1. What they want you to do is they want you to take that point, take the x value, and subtract 4. So it's now 0 minus 4, comma, and then the y value, they want to take it and do +2, which would be -1 plus 2. Essentially, taking this point and moving it to -4, comma, +1. And what you'll notice is if you graph that new point, so it's at -4, 1, 2, 3, 4, and then 1, that point is now -4, comma 1, which is U prime. But what you'll notice is that what all they did was they went 4 to the left, 1, 2, 3, 4, and then they went 2 up, 1, 2. So when you read this mapping notation, it's telling you 4 left because you minused 4 from your x values, and then 2 up because you added 2 to your y values. Now, mathematically, this is what it looks like, the math side of things. That's why they're writing it in such a weird notation, because they're saying take your x value for every point and subtract 4. That's the same thing as saying go 4 to the left. Right? This is just a mathematical approach to it. I think it's easier to just keep doing it the way we've been doing it. So if I look at point Q, instead of doing all that mapping notation, I'm just going to go 4 to the left and 2 up. So I'm going to go 1, 2, 3, 4, and then 2 up, 1, 2. And I now have that point there, which is Q prime. I'm now going to do the same thing with L over here. So I'm going to take point L. I'm going to go 4 to the left, 1, 2, 3, 4, and then 2 up, 1, 2. And it happens to be exactly on point Q, and that's okay. And then I connect the dots. So if I go from Q to U, L to U, Q to L. I have now taken my shape and I've moved it 4 to the left and 2 up. Or what I've done is this mapping notation right here of x values minus 4, y values plus 2. Cool. If you want to look at question D over here, I would like you to try that on your own. So this is a mapping notation question. Try to take that shape and move it and then unpause the video and look and see if you did it right. Okay, so to do this question effectively, you have to understand what this mapping notation means. When they say x plus 6, it means you're going to take all the x values and add 6 to them, effectively taking each point and going 6 to the right. When you read the second one, that's saying take all your y values and subtract 1, effectively taking all of your points and going 1 unit down. If you did this properly, that means point E should go 1 down, 6 to the right. 1, 2, 3, 4, 5, 6. So E prime is now there. If we do this with point I, we would go 1 down, 6 to the right. 1, 2, 3, 4, 5, 6. So it's right there. And we're going to do the same thing with point X. We're going to take that point. We're going to go 6 to the right. 1, 2, 3, 4, 5, 6, and then 1 down. So it's right there. Then our job is to just make the shape by connecting the corners so that we get this. We've taken the exact same triangle and we've moved it over here. You should notice with transformations, the shape doesn't change, right? Just like when we did our enlargements and our reductions in the previous units, the shape doesn't change. It's just moving, right? Like that's the identical shape. The angles are the same. The length of each line is the same. It's just moving. That's what a translation is. We got 2 more questions here. Try both of them for practice, and I'll put the answer up. So this first one would be 0 units left or right. So that would mean no left or right. That's what the 0 means. The 6 or negative 6 would mean 6 down. This means that you should have taken each point. I'm going to take point A and go 6 down. 1, 2, 3, 4, 5, 6. A is now there. You should have taken point J and gone 6 down, which is 1, 2, 3, 4, 5, 6. J prime is now there. And you should have taken point I and gone 6 down. 1, 2, 3, 4, 5, 6 right there. I prime. And then connected the dots to make your shape. Awesome. If you look at F, if you read that, what I should have done with F, I'm going to zoom in a little bit here. I didn't realize I was so far zoomed out. What this means, x plus 2 is meaning 2 units right. Y plus 5 means 5 units up. So you should have taken this shape and done exactly that. This time there's 4 corners. So I'm going to move J, 2 to the right, 1, 2, and then 5 up. 1, 2, 3, 4, 5. J prime is now there. I should do the same thing for E. So E prime should have been right there. I'm going to do the same thing with M. So if I look up at M, it should have been right there. And I'm going to do the same thing with X. So X prime should have been right there. So I've taken all the corners and I've moved them 2 to the right and 5 up. I then just have to connect the dots so that I have my new shape. But I move my corners. And you should notice that the shape is identical. The shape didn't change at all. It's just moving locations. Fantastic. Sorry, I keep drawing lines every time I want to move things. Now we're going to work backwards. Okay, to work backwards, we're going to take these transformations and write them out using words and using mapping notation. I'm going to always do words because words is what we're best at, and then I'm going to try to represent that with mapping notation. Okay, so if I look at these 2 figures, The original one is whichever one doesn't have the prime. So see, for instance, I have Z and then Z prime. That means this is the old and this is the new. So my mapping notation should always go from old to new. And you know that based on which one has the apostrophe next to it. You only have to do 1 point. And that's kind of the beauty of translations because all the points move the same way. So all you have to do is figure out how 1 point moved, and that'll tell you how all points moved. If I'm looking at Z, if I wanted to use words to describe how it's moved, I would say it's gone 1 down and then 1, 2 to the right. I think it's smart to always write it down in words, or at least try to describe it in words, so that you know what happened. Because we're good at that, right? Like that part's easy. If we want to represent this with mapping notations, we need to realize which one of these are X's and Y's, right? So if I move left or right, those are my X's. If I move up or down, those are my Y's. If I move to the right, that means I had +2. If I move down, it means I had minus, and then however many units it was is 1. So I've now created what my little formulas are. I just need to write them properly. So you always go X, Y, and then you do a little arrow, and then you write in your new mapping notation. So X became X plus 2, and then I put a little comma, and we said that Y became Y minus 1. And I got that from down here, right, where I did all that work and circled stuff. But this is my mapping notation answer. That's how I show a translation using mapping notation. You do this in math, math 30-1 mainly. Okay, looking over here, B. To do this, you have to figure out which one's new, which one's old, and find just 1 point and work with the 1 point. Let's work with point I over here. So if I look at point I, this is the old, this is the new. I know that because of the little apostrophe that's on the I, right? Like that little line right there, that means it's the new one. Perfect. We want to move from old to new. When we do that, we went 1 left, and then we went 1 up. To me, it's easiest to start with words. So 1 left, 1 up, and then turn that into mapping notation. If I wanted to represent 1 left, left is my X's, so I have X, and because it's left, it's minus 1. If I look at my up is Y values, right? Y values go up and down. Because it's up, it's plus, and then it's 1 unit, so it's +1. To write this out as mapping notation, I always have to say, okay, you started with X and Y coordinates. You moved every X and Y coordinate from X to X minus 1, and then from Y to Y plus 1. And that's your mapping notation. Beautiful. There's 2 questions there. I want you to try both of them. Pause the video, try them, come back, see if you get them right. All right, so hopefully you tried that. For C, the first thing is to recognize which one's the new and which one's the old. I started at H, so that's my old one. And then my H prime is my new one. It went 1, 2 to the left, and then it went 1 down. The way we represent that is by saying take your X's and Y's. 2 left means take all X values and subtract 2. 1 down means take all Y values, subtract 1. And that's my mapping notation. If we look at D, I'm going to move point B because that seems easiest. You have to know which one is the old one. The one without the apostrophe is the old one, and which one's the new one. Otherwise, you're going to be doing everything backwards, right? To get from old to new, I went 1, 2, 3, 4 up. I did not move left or right at all. So to do that, you say XY moved, so the arrow, so that the X values, and then you don't do anything because it didn't go left or right, so you didn't add anything to go right, you didn't subtract anything to go left. If you put +0, that's okay, but we don't need to do that, right? If we just say nothing, that's the same thing as saying +0. So we just leave our X values, and then we want to represent 4 up. We do that by saying all Y values get added 4 to move them 4 up. And that's mapping notation. Fantastic. We can do translations now without actually having to have a picture. So we have two examples here where we're going to translate these points and we don't have a picture. To do that, we're going to kind of use mapping notation. So this says translation 3 units right, 5 units down. If I'm moving units to the right, it means I'm taking my X values and I'm adding 3. If I want to do 5 units down, that means I'm taking my Y values and I'm subtracting 5. So for instance, if I wanted to translate point A, doing exactly what I just said, it means I would have my X value of 0, and then I would add 3. Then I would take my, I want to do that in red. There we go. Sorry, brain fart. Then I want to take my Y value of -1, and I want to subtract 5. That is doing exactly what I set up here. Take my X value, add 3. Take my Y value, subtract 5. And then calculate where your new point is. It would be at 3, -6. That is where A prime is. So I can fill that in. It's at 3, -6. Easy, right? So that way you don't actually have to have a picture. And that's typically what we see more of in Math 30-1. We don't have pictures. We're just moving random points that have to do with something that you just haven't learned yet. Which is why mapping notation is so important, because then there's not a visual anymore. I'm just doing it with math, with points, mathematical representations of pictures. I'm going to do B kind of slowly, and then I'm going to do the rest pretty quick. So if I look at point B is -2, 8. I want to take that -2 and I want to add 3. That would move it 3 units to the right. Then I want to take my Y value of 8 and I want to subtract 5. That would move my thing 5 units down. If I do that, I end up getting -2 plus 3 is 1. 8 minus 5 is 3. That means B prime is at 1, 3. Gorgeous. If you try this with C and D, C would be 2 plus 3 is 5. 4 minus 5 is -1. That's for C. And if you do point D, 3 plus 3 is 6. 0 minus 5 is -5. And that gives me my C prime and my D prime. 5, -1, and 6, -5. Awesome. The question below. Try your best. So see if you can translate those points. 4 units to the left, 6 units down. So pause and give it a go. Fantastic. Hopefully you did that. The first thing I have to recognize is 4 units to the left means I'm taking my X values and I'm subtracting 4. To figure out my Y values, to go 6 units down means I take all my Y values and I subtract 6. I'm going to do each one of these points kind of verbally. So if I have 7, 2, 7 minus 4 is 3, 2 minus 6 is -4. So my point is at 3, -4. My next point, I'm at -5, 4. -5 minus 4 is -9. 4 minus 6 is -2. That point has now moved to -9 and -2. If I look at my third point, 0 minus 4 is -4. -5 minus 6 is -11. That point has now moved to -4, -11. If I look at point D, I'm at 2, 0. 2 minus 4 is -2. 0 minus 6 is -6. -2, comma, -6. Fantastic. Our last question here. So now we're going to do two translations. We're going to do one translation using mapping diagram. I don't know why it zoomed out so far. So that is using mapping notation. I said mapping diagram. It's mapping notation. Then I'm going to do another translation using coordinates. Just a reminder, this means I'm going to take my shape. I'm going to go 9 to the left and then 6 up. Then I'm going to follow it by 3 to the right and 10 down. Perfect. I want you to try that. So you're going to translate it and then you're going to translate it again. Hopefully you paused and tried this. So I'm going to do it in 2 steps. Blue is going to be my mapping notation, so my first translation. Red will be my coordinate notation. So I'm going to take a point, like point A. I'm going to go 9 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 6 up. 1, 2, 3, 4, 5, 6. I now have point A prime is up there. Then I'm going to do the rest of the points. So if I look at point B, I'm going to go 9 left and 6 up, and it will get me right there. So B prime is there. If I look at point C, I'm going to go 9 to the left and then 6 up, which would give me right there for C prime. And then if I do D, I do 9 to the left, so 1, 2, 3, 5, 6, 7, 8, 9, and then 6 up. 1, 2, 3, 4, 5, and 6. So I now have D prime over there. I've effectively done the first translation, and it looks like this. You don't have to draw the translation. If you just did the points, that's fine. But I would want to see the points. It's basically just showing your work, right? So you're going to draw all those points. Now I'm going to do the second rotation. So this is my coordinates right here. If I was to read that, that means I'm going to take my coordinates and go 3 left and 10 down, which I've already told you. So I'm going to do that to my, I said 3 left. I read the negative on the wrong one. We're going to go 3 right. And then 10 down. So if I look, let's start with point A. So I go 3 to the right, 1, 2, 3, 1, 2, 3, and then 10 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I now have this new point right here, which represents A double prime. So it now has 2 apostrophes because I've done 2 translations, right? A prime was after 1 translation. This is now A double prime. And I'm going to do that with all the points. So B prime would do the same thing. It would go 3 right and then 10 down. It should get you right here. That is B double prime. If I look at C and I wanted to move point C, I would go 3 to the right and then 10 down. Which would get you right here. That's C double prime. And then if I did the same thing to D, I go 3 right and 10 down. I should get you 1, 2, 3, 4, right here. D double prime. And then again, you connect the dots to show your actual shape translated, not just the corners. Perfect. You will notice that the shape never changed, which is wonderful, right? It stayed the exact same through all those translations. And that's exactly what you want to have happen. Now, there is a trick that could make this go a little bit faster. That trick is that you could do both those translations at the same time. So if I took something and I did 9 left and 3 right, that's the same thing as saying minus 9 plus 3, which would be negative 6. That would be 6 left. So instead of having to do 9 left and 3 right, I could have just done all those points 6 left. And I could have done that same trick with ups and downs. So if I did 6 up and then 10 down, that's like having positive 6 minus 10. That's like doing negative 4, which is 4 down. And if you look, all my points, they are 6 left and 4 down from the original point. So you could have just done that if that's how you wanted to do the question as well. I much prefer doing it this way. Then I can see your work and I can see what you did and you did it right. And it's easy to kind of check through your stuff. If you mess up an addition or subtraction, which is really easy to do, then you get the wrong answer and you showed no work. So you get no part marks, which kind of sucks. Wonderful. I hope that you had a thrilling time learning about translations today. I know we did. My dog has been asleep for the entire lesson and not a peep has come from her. So it must have been a thrilling lesson. Enjoy the rest of your day, whatever time it may be. Take care of yourselves. Be safe out there. I hope to see all of you people very soon.